Alright, so this video is for showing how to do an ancova in SPSS. So let's just say that we have some hypothesis about the relationship between education and credit card debt in thousands. So if we click this button, it'll show what these different categories are. This is did not complete high school all the way to some college. If we look really quickly at the distribution, you can see that they're really far off in terms of their equality. So 53 compared to the lowest sample size condition here is 5 for college degree. So what I'm going to do really quick is recode this so we have similar group size. Okay, so we'll change that. We're just going to modify this so that it is did not complete high school and then completed high school. Well, okay. And then all we're going to do is toggle that. We will sort descending. And then we're going to change everything that's not a 2 back to a 2. Okay, so then when we go back and look at the information, we should have 2 roughly equal groups. So did not complete high school and then did complete high school. So we are good to go. Now, the next thing to do is to look for possible covariates. So we think that there's some relationship between education and credit card debt in thousands, but we have all these possible covariates, like years with current employer, current income, current debt to income ratio, and then other debt. These could all be possible covariates. So since I don't have any theoretical reason to assume any of these are possible covariates, all I can really do is assess them theoretically. So what I'm going to do is click on Analyze, Regression, Linear. I'm going to bring over my dependent variable of interest, which is credit card debt in thousands. Then all of these possible covariates, and keep in mind these are all scale variables. I'm going to select stepwise here. Enter is the default, but I'm going to select stepwise, then click OK. Alright, now this is going to tell you effect size essentially for each model, so R square, we'll go over that later. But then whether or not the model is statistically significant. So each model that is done, each iteration is a good model. But the important thing is to look at which predictors are statistically significant in the model. So what it's done here is it's going through these models sequentially. So think about this one being the first one it did, second, third, fourth, in that order. So what it's doing is it's entering one at a time. So this predictor was statistically significant. So that stays in for step 2. Then it adds another variable. It adds household income in thousands. It's keeping the other debt in thousands, but it's adding this one. Again, that is statistically significant. So in the third step, it keeps these previous 2 in there, and it adds a third one. It's adding debt to income ratio. That's a statistically significant predictor. But then notice what happens to this other predictor that we'd already had in there, other debt in thousands. When you add debt to income ratio, other debt in thousands is reduced, which means that there's significant overlap between debt to income ratio and this other debt in thousands, which makes sense. So essentially this variable, other debt in thousands, has become redundant. It's no longer worth its weight in this model. So when we go to model 4, what it's done is it's removed that predictor. So hopefully that makes sense. It was a predictor before debt to income ratio was added, but once debt to income ratio was added, it still maintained some predictive value. and other debt in thousands did not. So what this means is that these two variables here are potential covariates. So they're correlated or they're predictive of the dependent variable, and they're not redundant, because if they were redundant, as you can see from up here, they would have been dropped out, or one of them would have been, which is what happened to other debt in thousands. So these are our two possible covariates. Now if we go back, we can assess whether or not something is going on with the possible interaction. So it could be that homogeneity of regression is violated. Now in order to test that, we're going to click Data, Split File, Compare Groups, and then we're going to bring over Levels of Education. Click OK, and then we're going to click Analyze, Regression again. We're going to bring out hold on. So we've got to look back at our output. So in our output, we've got years with current employer and other debt. Wait. Okay, household income in thousands and debt to income ratio. So household income and debt to income ratio. These are the two covariates that we found. And then we're going to change this back to enter. And what it's going to do is it's going to show us whether or not we have statistically significant effects at each level, right? So click OK. Alright, so this is for did not complete, and this is for did complete. And then you've got the effects right here. So separately, you can see whether or not each covariate is a predictor of credit card debt in thousands at each level of education. So here's a t-statistic, the p-value, and it looks like everything is consistent. So we have effects for both predictors here when they didn't complete high school, and we have effects for both predictors here when they did complete high school, which means that homogeneity of regression is retained. We did not violate that, which basically means we can run the analysis. So click on Analyze. We're going to click on General Linear Model, Univariate. Level of education is your independent variable. Credit card debt in thousands is your dependent variable. We now know that household income in thousands is a covariate, and debt to income ratio is a covariate. Now if we click on Options, we can select Education here, Descriptives, Estimates of Effect Size, Continue. If we want to get some means plot, we can do that, and then OK. And I always forget to do this, but we've got to go back and change this so it's off of split file. You can always just click Reset as well. Click OK, and then we'll just run the analysis again. Okay, and here we have it. So, we've entered our covariates. We've got debt to income, and then we've got income right here. Again, although they're statistically significant, this is not important. We've already assessed whether or not they're predictors of the dependent variable, and they are, so we don't need this as further validation. What we're most interested in is this education. So you can see the F value is below 1, which automatically means there's nothing going on. The P value is 0.53, small effect size, so nothing's happening. And you can kind of see that right here. I mean, although this looks like there's an effect, if you look at the y-axis, nothing's really happening. So how you would interpret this is that after controlling for household income in thousands and debt to income ratio, educational level was not a significant predictor of current credit card debt in thousands. Alright, so hopefully that helps a little bit. If it doesn't, just let me know.